Hi, we're going to solve a problem that's going to require us to use the washer method. And first, let's make sure I'm on a pen. Okay, so we want to find the volume of the solid generated by revolving the region bounded by y equals x squared plus 1 and y equals x plus 3 about the x-axis. So, like with all of these problems, the first thing we want to do is sketch what's going on. So the x squared plus 1 is kind of a standard parabola, but the y-intercept has just been shifted up 1. So this is x squared plus 1, and then x plus 3 would be the straight line with the slope 1 and y-intercept 3. So, it'd be about there. Okay, so what's happening is we've got this region, and we're thinking about rotating it around the x-axis. Now what's actually going to happen there, let's see if I can try to draw this the way I want. We would get another piece. Think about rotating it around. This straight line would be the outside, and the parabola part of it would be the inside. And so if you think of one cross section, we're going to get something that looks like a washer. Okay, so where the outside edge is made by the x plus 3, and the inside hole is made by the x squared plus 1. So remember, here is our formula for how we use the washer method. And the first thing we want to do is find our limits, our a and our b, and that's going to be from this x value up to this x value. So another way of thinking about that, it's the two intersection points of these curves. So we're going to find where x squared plus 1 intersects with x plus 3. So I'll move everything over to one side. I'll have x squared minus x minus 2 equals 0. This factors as x minus 2, x plus 1, which gives me x equals 2 and x equals negative 1. So this tells us that's negative 1 and this is 2. So our limits are going to go from negative 1 to 2. We always have this pi. And then we're going to put our outer radius, square it. So our outer radius is the line, the x plus 3, so in parentheses. Oops. Sorry, that was just a random line. But we're going to have x plus 3 squared, and then minus our inner radius, which comes from the parabola. So we'll have the x squared plus 1 squared. Okay? Now, and then dx. This may look complicated, but all it really takes to integrate this is a little foiling. Foil out x plus 3 times x plus 3. Foil out x squared plus 1. Make sure you keep that in parentheses so you distribute the minus. And then you would just use simple integration. Now, I'm going to pull out the pi, and just to keep the video short, I'm just going to tell you what this integral is. So from negative 1 to 2 of x plus 3 squared minus x squared plus 1 squared dx. Again, not a hard integral to solve, but you could also put it in your calculator. That integral gives us 1/17 over 5. So when we multiply that by the pi, our final answer would be 1/17 pi over 5.